Okay, so video 1 for industrial electronic devices, week number 14 online learning. This is video 1 transistors. So I want to talk about the transistors that you have in your kits. There's two main types of transistors that we're going to talk about. So we're going to focus primarily on the Bjts. However, there are two main types of transistors. So Bjt stands for bipolar junction transistor. And it's controlled by a small input current versus a field effect transistor is controlled by a small input voltage. What I want you to do is there's two videos to watch. It's on YouTube by Veritasium. The first one is how does a transistor work? It's only 6 or 7 minutes, and same thing for this one here by Learn Engineering. It's a great company, does some really great videos, and that is transistors. How does it work? So what I want you to do is stop the video and watch those two so you understand how transistors work, and then come back to this video and continue on from there. So once you've done that, we'll talk about the Bjt type. So there's a picture here of the Bjt type, and there are 3 pins on these transistors. There is an emitter pin, there is a base pin, and there's a collector pin. For this type of transistor, this is the base pin right here. And we won't know, I mean, it's telling us, okay, pin 1 is emitter and pin 3 is collector, but we won't actually know until we measure them with our meter, and that will confirm what type of transistor, whether it's an NPN or a PNP type transistor, and also which other leg we're dealing with, whether we're dealing with the emitter or the collector leg, and I'll show you how to do that in another video. So this is a pictorial. That looks very similar to the type that you have in your kit, and this is a schematic diagram of your transistor, and again it has a base, an emitter, and a collector. Okay, so the two types of BJTs, bipolar junction transistors, are NPN and PNP. Now an NPN type consists of 2 N-type materials that are sandwiching a P-type material. So you can see an NPN, so we have N-type material, P-type material, and N-type material. So it's very similar to diodes in that this semiconductor material is more negative. In other words, as an excess of electrons. The P-type material is going to have holes for electrons, and then we have N-type again, so more electrons, excess electrons. So you can think of it as N-type, so negative, positive, negative, and then we have a positive, negative, positive over here. So we have a positively doped material, a negatively doped material, and another positively doped material. Now I want to point out here, if you look at the schematic symbols here, we see that we have a difference between these two schematic symbols. The one on the top has the schematic symbol with this arrow pointing, this arrow here pointing out. And this one has the arrow pointing in. So there's a real easy way to remember this. I've written it down here. So notice the schematic symbols above. The PNP schematic has the emitter lead with an arrow pointing inwards. The NPN transistor has the lead with the arrow pointing outwards. So we've got the PNP. So you can think of this as PNP, so arrows pointing in. A lot of times you say, okay, well, it's pee in pot, kind of looks like a pot and somebody's peeing in the pot. That's an easy way to remember it. NPN or not point in. So PNP points in, pee in pot, sort of looks like someone's peeing in a pot. PNP point in pot, and the NPN or not point in pot or not P in. So a couple of ways to remember that, and it's just a way of identifying the schematic symbols. So if you see this arrow pointing in, I always just say, well, it's pointing in, P in pot. This one's not pointing in, NPN not point in. There are 2 junctions. So let's talk about the junctions. There's a collector to base junction called the CBJ or CB junction, and the emitter to base junction called the EB junction. Now let's take a look at the collector to base junction. So we'll say, just for argument's sake, that this is the collector and this is the emitter. And this is always the base. This is the base. Center pin is a base. We'll call this one the collector and this one the emitter. Of course, we're not going to know until we start ringing it out. But there is a junction that is happening here, and that junction is where these meet, where the P and the N-type material meets. There's two junctions here, you see. So we got an NP junction and a PN junction. But there's also the junction where the base meets the collector. This is the base here meets the collector, and this is called the CB junction, or the CBJ. And then over here where the base meets the collector, we'll do it in a different color here, so where the base meets the collector, or so the emitter, where the base meets the emitter, that is the EBJ, or emitter base junction. And same thing here. So we have a collector, we have a CBJ and an EBJ here. So a collector to base junction and an emitter to base junction. The emitter to base junction is always connected forward bias. Always connected forward bias. A small base current is used to control a much larger output collector current. The collector base junction, or CBJ, is always connected reverse bias. And the collector biasing voltage must be higher than the emitter bias forward bias voltage. So what I'm saying there is that if you've watched those videos that I've asked you to watch, the Veritasium and the Learn Engineering videos, you will see that what happens as we start to get a small amount of current flowing through here, it causes a larger value of current to start flowing through here, like that. And that would be connected up to a power supply, like this. So hopefully you've watched those videos so you have a better understanding of how they work.